Hi, welcome to Unit 4, Lesson 4, Part 1, Introduction to Related Rates. This section covers Topic 4.4 from the 2019 Course and Exam Description for AP Calculus. Introduction to Related Rates. There are two standards for this section. CHA 3.D.1, the chain rule, is the basis for differentiating variables in related rates problem with respect to the same independent variable. CHA 3D.2, other differentiation rules such as the product rule and the quotient rule may be necessary to differentiate all variables with respect to the same independent variable. Our instructional objective is that students will be able to calculate related rates in order to solve problems in applied contexts. And our inquiry question is, how can derivatives help us solve real-world problems involving related rates? Take a few minutes and look at these standards. Think about what they mean and how they might be assessed on the AP Calculus exam. In this section, we want to look at specific rates of change and write them using calculus notation. In number 1, we have the volume of a cylinder is increasing at a rate of 6 cubic feet per second. This is a change in volume versus time. And so we'll write dV dt is equal to 6. And since this is an increase, it's a positive 6, and the units will be cubic feet per second. In number 2, we're told the depth of water in a rectangular pool is decreasing at a rate of 2 inches per hour. Vertical measurements such as depth and height are typically denoted with h for height. So we'll write this as dh dt equals -2 since we are decreasing, and the units are inches per hour. In number 3, we're told at rush hour, the number of vehicles going through the SunPass toll booth is increasing at a rate of 85 vehicles per hour. In this case, we're talking about a volume of vehicles and a change in that volume. And so dV dt is equal to 85 vehicles per hour. Now let's look at number 4. Air is escaping from a spherical balloon at the rate of 15 cubic centimeters per second. This is a change in volume and it's decreasing, so this will be a negative rate. dV dt is equal to -15 centimeters cubed per second. Beginning in number 5, we're told that we will be given formulas and we should take the derivative with respect to time. Remember to consider which variables change with respect to time before you take the derivative. Here we have the area of a rectangle and it's equal to length times width. And so to take this derivative, we're going to use the product rule as both of these dimensions may be changing with respect to time. So here we have dA dt is equal to the first, L, times the derivative of the second, dW dt, plus the second, W, times the derivative of the first, dL dt. In number 6, we have the circumference of a circle, which is going to be changing as a function of r. So dC dt is equal to 2 pi times dr dt. In number 7, we have the volume of a cube given as s to the third power, where s stands for the side length. And so dV dt is equal to 3s squared times ds dt. In number 8, the lateral surface area of a cylinder is given by s equals 2 pi r times h. And again, both of these may be changing with respect to time. And so we have ds dt is equal to 2 pi times, and we'll differentiate the product of r times h. The first times the derivative of the second plus the second times the derivative of the first. In number 9, we have the area of a circle, a function of the radius. And so we have dA dt is equal to pi times 2r dr dt, and this is equal to 2 pi r dr dt. The perimeter of a square, p equals 4s, is going to be dp dt is equal to 4 times ds dt. In number 11, we have the volume of a cylinder. And again, we're going to use the product rule to differentiate, as we have radius and height, both of which could be changing as a function of time. So we'll write dv dt is equal to, and we'll factor the pi out since it's a constant, and differentiate the first, r squared, times the derivative of the second. So the derivative of h is going to be dh dt, plus the second, h, times the derivative of the first, r squared, which is 2r times dr dt via the chain rule. So dv dt is equal to pi r squared dh dt plus 2 pi r h dh dt. In number 12, we're given the volume of a cone. Volume of a cone, again, has r squared times h, so we'll be differentiating via the product rule. We have dv dt is equal to, and 1/3 pi is a constant, so that's going to come out front. We'll factor that out, times the derivative of this product. So r squared times dh dt plus h times 2r dr dt. And so dv dt is equal to pi over 3 r squared dh dt plus 2 pi over 3 r times h dr dt. In number 13, we have the volume of a sphere, and so it's the radius that's going to be changing as a function of time. And so we have dv dt is equal to, and so differentiating r cubed via the power rule will bring our constant out front, 4/3 pi times 3 r squared and then dr dt. And so that gives us dv dt is equal to, the 3's cancel, 4 pi r squared times dr dt. Number 14, the side lengths of a triangle given by the Pythagorean theorem, x squared plus y squared equals 25. In number 14, we have the side lengths of a triangle given by the Pythagorean theorem, x squared plus y squared equals 25. And we're going to differentiate both of these with respect to time. And so we have 2x times dx dt plus 2y times dy dt is equal to, and the derivative of 25 is 0.